Okay everybody, welcome back. What I'm going to show you now is how to draw a graph of a parabola using EZGraph. Now what we usually need for a parabola in order to draw it is 3 points. Okay, so I've got an equation here, y equals x squared minus 4x plus 3. This is a parabola, and what we want to do is, well, if it's going to have a y-intercept, every parabola does. Every parabola that's a function of x, and it may have x-intercepts. If it does, then we're going to use those two intercepts to get 3 points, 2 x-intercepts and 1 y-intercept. Okay, so to find the y-intercept, put in a 0 for the x. Alright, you do that. 0 squared minus 4 times 0, these both go away. You get y equals 3, the only survivor there. Okay, so the y-intercept is 0, 3. So I'm going to go over here to my point tool, and I'm going to put it on top of 0, 3 and mark that point. Okay, now if this equation has x-intercepts, I would find them by putting a 0 in for the y. Okay, so in this equation we put a 0 here for the y. So we have 0 equals x squared minus 4x plus 3 equal, okay, and we want to see if this has a solution. Alright, fortunately it's already equal to 0, and doubly fortunately it turns out that we can factor this thing on the right hand side. If you multiply this out, you will see that this is what you get. Now if you can't factor it, that doesn't mean it's hopeless. It means that you either have to complete the square or try the quadratic equation. Okay, now it may turn out that this one simply doesn't have x-intercepts because you may get complex roots for this equation. That's not the case here. Alright, we do have 2 x-intercepts. When is this equal to 0? Well, it's either when x minus 1 is equal to 0 or when x minus 3 equals to 0. Or when x equals 1 or when x equals 3. Okay, so we got those as our x-coordinates of our 2 intercepts. So if I put 1 in for x, I get a 0 for y, as I can see here. And if I put 3 in for x, I would likewise get a 0 for y. So there's my two x-intercepts, 1, 0, and 3, 0. Alright, so let's just go ahead and plot those points. 1, 0, which is right there, and 3, 0, which is right here. Okay, now we're going to try and draw the parabola. Alright, I know it slides down between these 3 points. That's the only way a parabola is going to fit through here, is to come this way. Okay, so come over here to our curve tool and click on it. Now you start at one of the endpoints. Don't choose the one in the middle. Now draw between the endpoints with the curve tool. Now you've got to slide the middle point down in such a way so that it slides through both of these intercepts. I'm sorry, both of these intercepts here on the x-axis. That's approximately where it is. Alright, that looks about where it goes through both of them. So I'm going to click on that, and there, I've got that much of the parabola. Now to complete it, well, you could plot some more points, but I think if these are the points of interest, then you can pretty much eyeball it. Take your curve tool out here a little bit, drag it up. I mean, we don't have to be perfect with this because after all, in these problems, we're really concerned with the intercepts, maybe the vertex down there at the bottom. And you can compute the vertex in the mathematics. Alright, so I'm going to bend this out a little bit so it looks kind of normal. It looks more like a curve, and I'm going to repeat the same thing over here. So I'm kind of fudging it here at the end, I'll admit that, but what's important at that is that these points are labeled correctly. Use the text tool for that. Now, if we do not have two x-intercepts like we had in this equation, then what you have to do is you have to find 3 more points. And you have to maybe find the vertex. Now, how do you find the vertex in a problem? Okay, well, if we want to pin this vertex down, we can do it. How do you find the x-coordinate of the vertex? How do we find that? Well, that's minus b divided by 2a, right? So what's b in this equation? It's 4. So minus b would be, excuse me, b is minus 4, so minus b would be 4 divided by 2a. What's the coefficient of the x squared in this problem? 1. So we divide that by 2. 4 over 2 equals 2. Okay, so the x-coordinate of the vertex occurs here at 2. All right, that's no surprise, but what we need is the y-coordinate. We would evaluate at x equals 2 to get the y-coordinate. So what's our equation here? Y equals x squared minus 4x plus 3. If we evaluate that at the point 2, we have 2 squared minus 4 times 2 plus 3. So what does that evaluate to? 2 squared is 4 minus 4 times 2, that's a minus 8 plus 3. So 4 plus 3, 7 minus 8. Well, that's a minus 1. Okay, so that would be our vertex. It would be at 2 comma minus 1. Now if we look at our graph, well, it looks like I didn't make a very good guess there. It looks like it's dipping down below that. So if the vertex is a priority in drawing this graph, then make sure to compute that first so that you can get it correctly placed here on the graph. And don't forget the undo key. The undo key can save you from a lot of troubles because, well, in a situation like this, you just smack the undo key until you get back to a place that you like. And here, you want to put your vertex on there and draw around that, then do that. Now we'll get a more accurate picture because we have this 4th point. So when you draw this graph, start with these 2 intercepts and put the vertex in the right place. Then you can worry about linking it up to the y-intercept and going this way. But I'll leave that to you. I think you can handle it. Okay, that's how you make your basic parabola in EZGraph. Now remember, if it turns out you don't have x-intercepts, then just pick 3 other points and join up the 2 endpoints and the one in between, and then kind of get the ends of the graph drawn out from that. All right, thank you very much.